In this problem, we have a spherical snowball that is melting and its surface area is decreasing at a rate of 1 centimeter squared per minute. So since surface area is labeled SA, usually we will label this rate as dSA dt. And since it's decreasing, our rate is negative. So we have negative 1 centimeters squared per minute. We want to find the rate at which the diameter decreases when the diameter is 10 centimeters. So we want to find dt when d equals 10 centimeters. So we want to write an equation that relates all of these variables. And if you Google the surface area of a sphere, we get the equation SA equals 4 pi r squared. However, in this equation, we're not dealing with the variable r, we're dealing with diameter. So what we want to do is replace r with 1/2 d, since r equals 1/2 d. So we get 4 pi times 1/2 d squared. And if we simplify that, we get 4 pi times 1/4 d squared. And that just simplifies to pi d squared. So now we're ready to take the derivative of the surface area formula. So we get dSA over dt equals 2 pi d dt. And since we're solving for dt, I'm going to divide by 2 pi d. Since I know that dSA over dt is -1, I'm going to replace that with a -1. So I know that dt equals -1 over 2 pi d. So now we want to know the rate that our diameter is decreasing when the diameter is 10. So now all I'm going to do is plug in 10 for the diameter. So I have the final answer of -1 over 20 pi, and the units would be centimeters per minute. In our last problem, we have a kite that is 100 feet above the ground, and it's moving horizontally at a speed of 8 feet per second. So I'm just going to label the horizontal distance x. And now we know that dx dt equals 8 feet per second. At what rate is the angle between the string and the horizontal decreasing when 200 feet of string have been let out? Okay, so we want to find theta, and theta is our angle of elevation right there. And we want to find that for when 200 feet of string have been let out. So I'm going to label this S for the string. So now we need to make an equation relating all of our variables. So for this particular one, we need to use the angle theta, since we are going to be solving for d theta dt. We also want to make sure that S is somehow involved in our equation. The reason for that is, well, X could be involved also. It really doesn't matter which one that we use. but we will have to plug in either s or x depending on what type of equation that we write. So there's a few different ways that you can do this problem. I'm going to use tan theta. So I'm going to say that tan theta equals 100 over x. And actually we do need to use tan theta because we don't know ds dt. So if you set up, for example, a sine equation, sine theta equals 100 over s, when you take the derivative, you don't know ds dt, so that equation wouldn't work for you. However, this equation will work when we take the derivative because we will get secant squared theta, d theta dt, and really quick before I take the derivative, I'm just going to rewrite this 100x to the negative first. So I get negative 100 x to the negative second. And again, we want to solve for d theta dt. So I'm going to divide by secant squared theta. So I know that d theta dt equals negative 100. And I'm going to turn my secant squared theta, since it's in the denominator, to a cosine squared theta. And I'm going to send the x to the denominator, so it's just an x squared. All right, so now we are ready to solve the problem. So we want to know the rate that the angle is changing when the string is 200 feet long. So we have a place to plug in theta and we have a place to plug in x. I forgot to do a dx dt when I took the derivative, so let me back up and put it right there, and then we'll put it up top here. There we go. Okay, so now we have dx dt in there. And we know that dx dt is 8, so we can change our equation to negative 800 cosine squared theta over x squared. All right, so that is our final equation for d theta dt. So if I know that the string is 200 feet and the height is 100 feet, I can solve for x, and then I'll have my x to plug into my equation. So if we do Pythagorean theorem, we have that 100 squared plus x squared equals 200 squared. So we get that x equals 100 root 3. And that makes sense because if we look at our triangle, the hypotenuse is double the height, which means that we're dealing with a 30, 60, 90 triangle. So we know that our theta is 30 degrees or pi over 6. So we kind of killed two birds with one stone there. We found the side and we found the angle, since we recognize that this is a special triangle. So now to find d theta dt, I'm going to plug in pi over 6 for my angle. And I'm going to plug in 100 root 3 for x. So that gives me negative 800, and the cosine of pi over 6 is root 3 over 2. So if we squared that, it would just be 3/4. And then the bottom would be 3,000, or 30,000, sorry, we would need 4 zeros. And if we simplified that further, 2 of our zeros would cancel, and the 8 would cancel with the 4. So we would get negative 6 over 300, which would be negative 2 over 100, or negative 1 over 50. So our final answer for this would be negative 1 over 50 radians per second.